All right, guys, today we are going to add shifts to our trig graph. So we're going to be shifting it horizontally and vertically. Now, in the world of trigonometry, we do not call a horizontal shift that. We call it a phase shift. So you're never going to see that word horizontal. You've got to understand, though, that's what phase shift means. That is represented by C. Now, notice in this, B is factored out. Okay, and we'll talk about that again in a little, but you got to make sure that B is factored out. Basically, this is telling you, C, it's telling you the X value where the graph starts. So horizontally speaking, where am I going to see that first point in the period that I'm talking about of my curve? And then vertical translation, your vertical shift, this is D. Also, this represents our new, I'll call it new midline. Okay? Now, just to give you a visual of what I'm talking about here, if you look at this top curve here, this is your normal cosine curve, right? Starts at 0, ends at 2 pi, the amplitude is 1. All right? Now, if we look at this one below, I don't want to look at this as something that's been reflected or anything like that. I want a normal cosine curve. Well, here is a normal cosine curve. And so if we look at this, not only has this cosine curve shifted to the right, this point went over here to the right, but also it then shifted down. Okay? So this is what we're going to be looking at today. And then we're going to put it all together. All right, so first one. Now hopefully we remember kind of our rules of formulas when we see a negative in a formula. So let's just go back up here and look at this for just a second. When you see this negative in a formula, it's telling you to do the opposite. So we're always going to do the opposite of whatever is in here. The plus means do what it says. So D is what it is. So we're doing the opposite of C, and D we're going to do exactly what it says. So this says minus pi over 4. Okay, that's my C. What this means is my graph is moving right pi over 4. So we're going to start the sine curve at pi over 4, not 0. Then we have D right here, plus 3. This means my graph is moving up 3. Okay, that's going to represent my midline. So if I go up 3, okay, this is my new midline. And remember, sine starts at the midline, okay? So my first point is going to be on the y value of 3, not 0. Now, my amplitude, still positive, it's just 1, right? Meaning from the midline, we're going to go up 1 and we're going to go down 1. That has not changed. So if we want to label that, we can do 4 and 2 here. Okay, so amplitude is still 1. Also, we don't have anything here in front of x representing a b, which means our period is not changed. Okay, so that's important. So first off, pi over 4, actually change and make that the same color, pi over 4 is where we are going to start this. How do we know when it ends? When do we end one full period? Well, period is 2 pi, okay? That hasn't changed. So think about this. If I start at pi over 4 and I need to go an interval of 2 pi, I'm going to add 2 pi to this. 2 pi is 8 pi over 4. So that gives me 9 pi over 4. Okay? So this is where my graph is going to stop. That will give me a total interval of 2 pi. Okay, now we're still going by pi over 2's. That has not changed. That only changes if you have something up here for b, if we're changing the period. So we're going to add pi over 2. So pi over 2 is equivalent to 2 pi over 4. So what we're really doing each time is we're adding 2 pi over 4. So we've got 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then we'd be back to 9 pi over 4. All right, so we're going to start this at pi over 4. All right, sine starts on the midline. And then we're going to go up 1. and then we're going to come back down to the midline, and then we're going to go down 1, and then we're going to come back up to the midline. And there's my curve. Now, domain is still all reals. We already said the period is 2 pi, okay? The amplitude is 1, just like the parent graph. What has changed on this one is the range, okay? So the range on this one is 2 to 4, okay? 2 to 4. All right, so now we're going to put it all together. All right, putting it all together. Now, number 1, actually, I'd like to move this up here and make this number 1. We want to factor out b if it hasn't already been factored out. Then we're going to find the midline, which that is represented by D. Then we're going to ask ourselves, where does the graph start? That is represented by C. Remember, we're going to do the opposite of that. Then we're going to figure out what is the period of our graph. That is what we use B for, okay? We use B for that. And then we're going to divide this into force, always force, and we look at the amplitude because that tells us how far up and down from the midline we need to go. All right, so let's look at our first example here. We have y equals 2 times the sine of 3 theta plus 90, and then plus 4. All right, so I'm going to go over here, and I am going to factor out that 3. So 2 times sine of 3 times theta plus 30 degrees plus 4. All right, next thing I'm looking at is the midline. The midline comes from D. D is plus 4. So I'm going to go up 4, and this is my midline. Okay? Then I'm going to say, well, where does my graph start? That comes from C. This says plus 30, which means I'm actually going to go left 30 degrees. So I'm going to go left 30, which would put me at negative 30 degrees. All right, then think about the period. Well, normal period, I'm going to come down here and do some work. Normal period is 360 degrees, but I'm going to divide by B, right? We're going to divide by our B, which is 3, which would give me 120 degrees. So that tells me if I start at negative 30, my full interval needs to be 120, which would put me at 90 degrees, right? Negative 30 to 90 is 120. Then we want to divide this into fourths. So I'm going to take that 120 degrees and divide by 4, which gives me 30 degrees. So something's going to be happening every 30 degrees. So I'm going to have negative 30, 0, 30, 60, and then that would bring me back to 90. All right, then last thing I want to think about here is my amplitude. So amplitude is 2. So this means I'm going to start at negative 30, like on the midline for sine. Sine always starts on the midline. And instead of going up 1, I'm going to go up 2. So we're going to go up to 6 here. So we're going to go up 2. Then at 30 degrees, we're going to come back down 2. At 60, we're going to come down 2 more. And then at 90, we're going to be back at the midline. Okay, so if we look at this graph, it has an amplitude of 2. Okay, it had a phase shift, which means a horizontal shift. A phase shift, we say it went left 30 degrees. Okay. Our vertical shift, or our vertical translation, it's sometimes called, that went up 4. We know that the new period of our graph is 120 degrees. Okay, all things I could ask you about an equation or about a graph that you've already taken care of. All right, let's look at one more, and then we're going to do one evaluating one. All right, so I'm going to factor out the 1/2. So we have y is equal to negative cosine 1/2 times x minus, we're dividing when we factor. So pi over 2 divided by 1/2 is the same as pi over 2 times 2. So we're going to have pi and then minus 6. All right, first thing, and missed a parenthesis here. First thing we want to do is our midline, which is represented by d, which is minus 6. So we're coming down 6. So it's negative 6, and that's our midline. Okay, then we're going to look at where are we starting. That's a negative pi, which means we're going to go right pi. Okay, and just because of space, I'm just going to put it right here. So here's pi. Okay, all right, next thing, normal period is 2 pi. We're going to divide that by b, which is 1/2. Okay, divide by 1/2, same as multiplying by 2, so we get 4 pi. So this means I'm starting at pi, and I want to go a distance of 4 pi. So we start at pi, we need to add 4 pi to that, so that means we're going to end at 5 pi. So over here at 5 pi is where we're going to end. Okay? All right, then we want to divide this into fourths. So we want to take our period of 4 pi and divide that into fourths, which is pi. So something's going to be happening every pi. So we're going to have pi, 2 pi, 3 pi, 4 pi, and then we're back to 5 pi. Okay, but from start to finish is pi to 5 pi. That's an interval of 4 pi. Okay, also notice our negative here. So now we're thinking amplitude. Well, it's 1, so we're up 1, down 1, only instead of starting up, we are going to start down. So this one's going to look like an upside down cosine. So I'm going to go down 1, and that is where I'm going to start. Okay, and then with cosine, we're actually, sorry guys, we're starting at pi, not on the y-axis. Okay, and then with cosine, we're going up to the midline, and then we're going to go up again, and then we're going to come back down to the midline, and then back to the minimum where we started. And there is our cosine curve. Okay, so we already talked about this one. The period is 4 pi. The amplitude, remember it's always positive, is still just 1. I could ask you the range. It's -7 to -5, right? There's different things I could ask you here. The phase shift is right pi. The vertical shift is down 6. All things I could potentially ask you for characteristics. All right, so let's look at, let's just do number 2 here for time's sake, okay? So order of operations, remember, we're doing f of 210 degrees. So we're going to have -1/3 times the secant of 3 times 210 degrees plus 120 degrees. All right, so order of operations, inside those parentheses, we're going to do 3 times 210, which is 630 degrees. Then we're going to add those, and we get 750 degrees. Okay, if we find the coterminal angle, we would subtract 360 and then subtract it again. So we're subtracting 720. We would get 30 degrees. The secant at 30 degrees, well, cosine at 30 degrees is 1/2. So therefore, secant is 2. So we're going to have -1/3 times the secant of 30 degrees is 2, which gives us -2/3. Okay, -2/3. Now, a couple extra things I'm asking you here. What is the amplitude of this? Well, remember, secant has no minimum or maximum. So the amplitude is none. We can't have an amplitude if we don't have a min or max. Okay, then the period. To find the period, we take our normal period for secant, which you got to go back to your parent graphs for this. That's 360. We divide by b, which is 3. And so we get 120 degrees. So we'd have to go 120 degree interval to see one complete secant curve. Sorry, can't speak there for a second. All right, guys, so now we have graphed all the trig functions and done all of our manipulations.